Hi, thank you for your time. I'm Brian Hageman, CEO of Deluge Technologies, and this presentation has been produced for the WIFA Board of Directors and the Governor's Water Policy Council. We all saw last year with the Colorado River crisis that we need to diversify our water sources to have enough water for our future and to get through any new crisis that we might run into. My phase one project will provide enough water for 500 large homes in Phoenix, including irrigation. So that could be a lot more homes if we use conservation measures. Diversifying our water supply in the future needs all kinds of technology, new and old. This new hydraulic engine technology, the phase one project, is built for a 50-year lifespan. We've been building in shipping containers for a long time, and that's what phase one will be built in, is a shipping container. We started using shipping containers for our engines back at University of Arizona at the Maricopa Ag Center for our first water pumping tests that we did using solar thermal hot water as fuel. Our hydraulic engine needs hot water as fuel, 180 degrees Fahrenheit hot water. That'll be used on the phase one project. And we could get our hot water from various sources. Solar thermal with our thermal storage is great. Geothermal, 24 hours a day available. And natural gas is our backup fuel. When the sun's not out, we use natural gas, and we've incorporated natural gas into many of our projects. Our solar collector is unique. Each collector is a 20-foot by 20-foot plate to make 65 kilowatts of thermal energy, and it's a heliostat collector with 400 mirrors that all point to a collector in the middle that collects hot air for our thermal storage systems. Now, the great thing about our engine, the hydraulic engine, is that we don't change phase. That saves a lot of energy, not having to convert from water to steam. 212 degrees conversion uses up a whole lot of energy that we don't have to do. And again, natural gas is a great backup fuel, and I'm going to tell you about how it worked in a few of our projects. My experience in the petrochemical industry, building oil refineries around the world, led me to use the hydraulic engine in crude oil production. I came out of the industry, I knew a lot about it and wanted to see how our technology can work in the oil business. And the governor of Wyoming actually talked me into using his test center up in Wyoming. The Department of Energy's Rocky Mountain Oilfield Testing Center, RAMATSI, is where we won an award for the most outstanding technology development, and that was published in the Department of Energy Office of Fossil Energy magazine that year. Using geothermal hot water for this project works great. I hope we can find geothermal water through discovery in Arizona to utilize this great way of running my engine. After the successful testing in Wyoming, we moved to Kansas and built our own oil field in Parsons, Kansas. This is a really important project that we did. It was our first build, own, operate project. And that avoids me the technology adoption aspect of selling the technology. We don't have to sell the technology. We just sell crude oil, or in our phase one project in Arizona, we'll sell water and electricity. But this gave us the chance to start working with contract manufacturers. We drilled 9 oil wells, 1 natural gas well, and 1 water well and 1 water injection well. So we had a fully self-contained system using natural gas to make hot water, and ran our engines that pumped oil, and we sold crude oil to the local refinery. A couple of aspects technology-wise, these were the best heat exchangers that we've built over a span of 30 years this was the best heat exchanger, and this is what we'll be using in the phase one project. This coil in a casing type of heat exchanger. That photo above me is a cutaway of the heat exchanger designed with the coil in the cylinder, and that's been the best, fastest heat exchanger design that we've had. We also, a year after running the system, we took apart one of the pistons to inspect the piston seals. And after looking at them, they look brand new. After a year of use, these systems will run for 50 years with regular maintenance. Even our solar thermal project in Hawaii, with our 250 kW engine that we built, used not natural gas but propane in a tank that was used for startup testing and commissioning. We also used natural gas in the ASU roof project that I did while I was adjunct research scientist at ASU doing a Freon compression testing. And this whole project was sponsored by Southwest Gas. We were using solar thermal during the day and natural gas at night to do our Freon compression testing. It makes it a great partner. And for use in our phase one projects, our early phase one projects in Arizona, natural gas is the best suited fuel before we build out our phase two solar collector systems. We've continued working on desalination systems since our first desal testing with the Department of Interior in Yuma and ASU. We did a testing that was a report that was written by ASU and the Department of Interior Bureau of Reclamations on the testing we did at the Yuma Water Quality Improvement Center. It's the technology center. They have a R&D center at the Yuma desalination station, and they were great help in getting me started with the development of desalination. Since then, I've developed the small system that'll provide enough irrigation water from brackish water for 1 acre of farmland. And that system is ready for field testing. That uses our hydraulic engine in reverse osmosis pumping, just like the phase one project's going to do. In fact, the computer that ran the small system here is exactly the same program as we use for the phase one project in Arizona. The phase one project with natural gas can start in a bunch of different areas around the state, especially in Maricopa County, where there's 200 million acre feet of brackish water available underground right now. Northeast Arizona will become a big deal in the future because we could desalinate all the water that they have up there and pipeline it down to Phoenix and Tucson. We're ready to start drilling. I've got the well drilling instructions from our Phoenix AMA director, and we'll be selling wholesale water pricing with natural gas pricing at 92% of CAGRD rates. That's about $705 per acre foot. Our funding request to WIFA is for the $1.2 million phase one project using natural gas. This will do, again, 500 homes, and that works out to about $2,400 per home. Not that they're going to be charged that, but for a regular home in Arizona, in Phoenix, that cost several $100,000, $600,000 or $700,000, $2,400 is easy to claim that as a value for this type of project in Arizona. So we look forward to getting started. Our contract manufacturers here in Phoenix are ready to go, and we're looking forward to your go ahead.